Now we are in the conventional abrasive finishing processes. Till now we have seen the bonded type of conventional abrasive finishing process like grinding and corresponding grinding fluids, honing and all those things. Now we are moving in this particular class to unbonded conventional abrasive finishing processes like lapping, super finishing, sandblasting, vibratory bowl feeding and drag finishing, and we summarize about the abrasive finishing process. So, the first thing that I was saying is unbonded conventional abrasive finishing process, wherein the first process comes is the lapping process. In the lapping process, the parameters are like lapping wheels or the plates that are there, at the same time lapping medium and abrasives that are there, which are used in lapping process. So the lapping, if at all, if you want to finish any particular sample or the workpiece, you will have a lap, that is plate, wherein you have abrasive particles carrying medium and all those things. So we will see what is this lapping process and all those things. Lapping is basically an abrasive finishing process, machining process. If at all people are talking about machining, that is material removal, it is machining process. Otherwise, it is a finishing process. Mostly lapping process comes as a finishing process only. You don't bother about what the material removal. We always go for the finishing that is achieved on the final product. So which uses the loose abrasives for cutting points for this one. Lapping involves the cutting and the shearing action. This is of the loose abrasive particles in order to fine finish the components. Material removal, generally it ranges from 0.003 to 0.03 mm, that is the thickness, and but maximum it may reach 2.1 mm also, that is the material removal. That means that it is not a material removal process because the material removal is very minute. So the characteristics of lapping process, it uses the loose abrasive particles between lap and the workpiece, which you have seen in the previous slide. So lap and the workpiece are not positively driven, but it is guided in contact with each other, because there two contacts will be there. So in between the fluid as well as abrasive particles will be there, and it will be done like this. So there will be a fixed one, there will be a lap, in between the medium will be there, and the workpiece is fixed on the bottom, and you can do the lapping process. Relative motion between the lap and the workpiece, this is the most important, should change continuously so that the path of the abrasive grains of the lap is not repeated. Assume that if the path is not changed, what will happen? The finishing takes place on the same path. The workpiece is like this. If I have a lap on top and abrasive particles are there, if it rotates there itself, there is a possibility that the abrasive particle will follow the same track and create the scratch in the same. So you need to change the relative motion, you need to change the path. If at all the path has to be changed, then you should continuously change the path. So for that purpose, you should change the relative motion between the workpiece as well as the lap continuously in order to change the path of the abrasive. Lapping, normally the tool, which is a flat disc or a plate made up of normally soft type of materials such as cast iron, aluminum alloy, copper and brass. The abrasive mediums are carried out by medium. Basically medium is nothing but an agent which carries the abrasive particles like grease, oil, water, and high viscosity means a high abrasion. Normally if you are going for grease, what will happen? The viscosity will be very high. If the viscosity is very high, the material removal will be very high. That is what the meaning of the sentence is. There are two varieties of lappings are there. One, you just have the workpieces on the bottom, like the red ones. If you see the figure 1 and this is figure 2. In the figure 1, what is thing that I want to say is the workpieces are placed on the green one. These are the workpieces, and the lap will come on from the top and it try to finish. This is with respect to one lap. You can do on the both sides, like you will have a lower lap if you see the figure 2, and there will be a upper lap. So you will have two laps, in between you are holding the workpieces. So you can do the both ways, but the second one, figure 2, is quite economical, because for the same input you can do on both sides. So the main function of the lapping process is the finishing process. If you see the before finishing and after finishing, the finishing that you are going to get is better and better. So the before finishing, this is a surface, and after finishing, this is a surface. So what will happen that you are going to get a good aesthetic appeal, you are going to get better surface finish, that means low roughness. At the same time, you will have a high load bearing capacity and all those things. That this is a common for most of the finishing process, and lapping is one of the finishing process. That's why mostly you go for the finishing using lapping. If at all, if it is a flat surface or if it is a cylindrical surface and all those things, normally people go in a small scale industry for the lapping process. So lapping process, if you see in deep, there are the mechanism goes by 2D and 3D abrasions. Whatever I want to say is 2D abrasion. 2D abrasion means if there is no relative motion between two surfaces. Assume that grinding. In a grinding process, what will happen? You have a grinding wheel where you have abrasive particles are fixed, and you have a workpiece on the bottom. So there is no relative motion between abrasive particles and the grinding wheel. So that means that whatever the abrasion, if I give the depth of cut and all those things, what will happen? Same, approximately same depth of cut will be removed from the workpiece. Okay. So that is nothing but the 2D abrasion. In a 3D abrasion means in a 3D abrasion, what will happen? Lapping is good example. You have a workpiece on the bottom, and you have a particles, abrasive particles, which are carried by the carrier medium. So you have a lap on the top side. In that circumstances, what will happen? These particles are loosely bonded or these are unbonded. In that circumstances, the abrasive particles not only follow the path of the lap, but also has its own orientation or rotation about its own axis. In that circumstances, the abrasion takes place in the 3-dimensional. That's why it is called a 3D abrasion. So in the grinding process is a bonded abrasives, and the lapping process is a unbonded abrasives. So that means the unbonded abrasives have the freedom or independent to move about or rotate about its own axis also along with the axis of rotation of the lap. For that purpose, normally this lapping process is considered to be the 3D abrasion process. The lapping tool is rotated or oscillated, moved irregularly across the machine surface so that the random motion can be generated. If the random motion is generated, the surface finish will be better. So there are two types of methods, which are equalizing lapping, and another one is form lapping. So equalizing lapping removes the previous shapes or the flattening. This is the main purpose. Normally, if at all somebody I want to remove certain micro layers or nano layers, you can use. At the same time, you can use for the flattening the surface. For the form lapping, the lap is a negative shape of the surface. What will happen if at all I want to generate particular shape? Assume that I want to generate certain shape on a flat workpiece. What will happen? You will have a lap like this and you will rotate. What will happen? This negativeness will generate basically. So this portion you are going to get. So this is called the form lapping process. Negative shape will be there and you can generate it. That is the difference between equalizing lapping as well as the form lapping. The lapping process mechanism for the brittle materials and ductile materials goes like this. Just first we discuss about the ductile materials. Always ductile materials will go by chipping process only. That means that shearing process, like metal cutting process, whenever you are seeing the continuous chips in a ductile material and all those things, similar fashion the material removal takes place by the shearing of the surface of the workpiece by the abrasive particles that are involved in the lapping process. So there is a workpiece and your abrasive particle will come and it will take out a chip. So that is how the shearing takes place in this one, and gradual shearing takes place the surface peaks. This is about the ductile mode of removing material. But in case of brittle materials, if the workpiece is like a glass or if the workpiece is like a silicone, these are the brittle materials. Normally material removal in brittle materials is just first it will have a crack, then it will remove the in terms of the fragments as a chips. Okay, your chips are like fragments of the brittle material. This is how the material removal takes place in the most of the brittle materials, like cracking then followed by the fragments. In the ductile materials, it is like a shearing operation by the abrasive particles. This is the difference between ductile as well as brittle materials material removal. So lapping materials, if you see the lapping abrasive types, normally the abrasive types of like alumina, chromium oxide, and boron nitride, boron carbide, diamond, these are the mostly are commonly used abrasives in the lapping process. Medium, that is carrier medium, like whatever it carries and all those things, that is like machining oil, rape oil, grease. Mostly people will use grease if at all material removal want to be more. If at all material removal is requirement is less, in that circumstances you can go for low viscous liquids. The technical parameters, that is unit pressure, how much pressure you are going to apply on the workpiece, the grain size of the abrasive, that what is the grain size, whether you are going for a coarse grain, whether you are going for a fine grain or a medium grain, and all those things that will decide your material removal. If the grain size is coarse, the material removal will be very high. If the grain size is less, what will happen? The material removal is very low. So the concentration of abrasive particles in the vehicle, that means that agent or medium. Vehicle is also a word some of the people will use this. So the alternatively you can use say that medium or so the concentration of the medium. If the concentration of the abrasive medium in the agent, that means that if I am using 50% of the abrasive particles among the concentration, then material removal will be very high. If I compare to if the abrasives we are concentration if I am using like 20-25. So it's all required by the what type of requirement the particular operator have. If the requirement is finishing, you don't need to go for higher amount of abrasive particles. If you are going for the higher material removal rate, you have to go for coarse as well as high concentration. So that means coarse particle you have to go, and you have to go for higher concentration also. The lapping speed, if the speed increases, what will happen? The number of times the abrasives come in contact with respect to the workpiece will be very high, so the material removal also will increase. Since it is we are considering this particular course as a machining as well as machining fluids course, we should talk about mostly about machining. That's why if I am going to increase pressure, material removal rate will increase. If I am going to increase the particle size, material removal rate is going to increase. If I am going to increase the concentration, material removal rate increases. If I am going to increase speed, then material removal will be increased. That means material removal is primary concern. If you have to, then you have to increase all the 4 parameters. If you are finishing is your requirement, then you have to play according to the requirements of yours customized requirements. Okay, brittle workpieces, normally the abrasive parts is like diamond, you can use carbon, CBN you can use, silicon carbide, alumina and carborundum. These are the workpiece materials you can do the lapping. I mean to say these are the workpiece materials. These are all also as a tool materials, that means abrasive materials also, but you can also do these workpieces. But the only thing is that whenever you are using these workpiece materials as silicon carbide or aluminum oxide, then you have to choose your abrasive particles slightly higher than the hardness of your workpiece material. In that circumstances, you have to go for CBN, that is called cubic boron nitride, and all those things. So if at all you are going to do the lapping process for aluminum oxide, that is alumina, then you have to choose always higher hardness, that is like cubic boron nitride or diamond and all those things. That should be taken care with respect to this particular part of this slide. So the ductile workpiece materials, normally the ductile workpiece materials are like mild steel, copper, and these are all the one variety of the materials. The ductile materials getting surface finish is not that much easy, because the scratching is one of the prominent problem. That's why mostly the lapping process will be used for the harder materials, but you can also go for the ductile materials and softer materials. The various types of lapping process, if you see, this is called the surface lapping, where you have a tool will be there, workpiece will be there, and you just give the motion, the relative motion to both of these one. They are called spear lapping, where if at all I want to go for lapping of a spear, just you need to have a converse shape or the negative shape of it, and you can do the finishing process. Then cone lapping, again the converse shape you are going to have, then you are doing, these are all called profile lappings. If at all I want to do a profile, you have to have the converse of that profile, then you do the lapping process. Cylindrical lapping will be external cylindrical peripheral lapping is one of the process, external cylindrical face lapping will be another process, internal cylindrical peripheral lapping will be another process. So you can do whatever you want, but only thing is that according to your requirement, you have to change your tool. Medium, that is abrasive medium. Abrasive medium means abrasive plus the carrier, you should have selected according to your requirement. So another one is thread lapping, where thread lapping is external thread lapping as well as internal thread lapping. Two types of things are there. So you can go for here, and here also the shapes that the tool which will you have, or the lap that you will use will have the converse shape. These are the four varieties of the lapping process. So the mostly commonly used in the small scale industries is the hand lapping process. And if at all I want to do some batch or mass production of a particular components, people can go for the machine lapping. Okay, machine lapping, you can go in a one go multiple components and you can do the lapping process. This is about the lapping process, and the effects, if you see regarding the lapping process is concerned, the basic problem comes is scratches on the workpiece. If the workpiece is ductile or soft material, normally the problem will be like scratches on it. It is not only the polishes or the finishes, but also it generates its own scratch marks, because the hardness variation between the workpiece, if it is soft workpiece, the hardness will be much low, and if you are using a abrasive particle like CBN or silicon carbide, the hardness ratio is very high. In that circumstances, it not only removes the surface peaks, but also can generate the scratches on it. The second one is abrasive damage due to particle breakage. Since the abrasive particles are about the brittle materials, whenever you are giving the motion, random motion, they collide with another particles at the same time. By involving continuously with respect to workpiece, what will happen? Particle breakage will take place, and this may damage the workpiece also. The forces developed affect the properties of the workpiece surface. If the forces are very high, the problem will be that the material removal will be very high. The forces should be uniform across the surface, otherwise you will get a non-uniform surface roughness. These are the materials, abrasive materials. Normally you can go, or you can also do the finishing of this work as a workpiece materials also. So advantages of lapping, the advantage of lapping is high accuracy, the surface geometry, good quality, means aesthetic appeal will be very good, repeatability will be very good, and you can achieve the required tolerances and no warpage of the components. There is no warpage and no heat generation because continuously liquid presence is there. That means that medium presence is there. That's why there is no problem of heat generation in the lapping process. That's why most of the small to medium to large companies will go for the lapping process for the polishing or the finishing of any simple geometrical components. So the applications, if you see this before and after, this is the before and after the lapping process, and you can also see in a single go you can go for the multiple components. If you see here how many components they are finishing, if you see 2 to 10 in one set you are going. So this type of sets, multiple sets will be there. So it can also use for batch as well as mass production also. You can do the finishing on in a mass spectrum. So you can do for the braces, whatever the internal surfaces also you can use. And the most importantly, some of the high tech applications of the lapping is mirror like finishing. So you can use for the mirrors, you can see here these are the advanced type of mirrors where on one side you have a mirror surface and another side you have this type of texture. So these are all used for the high tech applications. Some of the applications, like one side you can go for the cooling application, on other side you can go for bombarding of some of the advanced rays and all those things. So this is having a wide variety of applications from the point of finishing. Now we move on to the super finishing. This is one of the conventional finishing process where you will use the coolant, where you can use the bonded abrasives partially as per your requirement. So super finishing is also known as a micro nano finishing. Thus this is achieved by removing just a thin amorphous layer that is about 1 micron in magnitude left by the previous process. If at all I want to use the super finishing process, I am going to use the previous process, that is like a grinding, or I am going to use the hard turning process. If at all, then I am going to do this finishing process, then you can achieve the surface. That means that whatever the layers that are left by the previous processes can be removed by the super finishing operation. The super finishing is unlike polishing, which produces the mirror finish and creates a pattern on the workpiece. That means that you have seen the picture. In that picture, it has a rotating workpiece and a brush type of, that is nothing but the plunge type of thing is there. So if it is rotating, not only it polishes the surface, but also it can generate its own pattern, that is nothing but the predominant direction of the surface finish. People, you might have seen in the first or second class where there is directrix and generatrix. So that the directrix will be formed on the, which is like a circle will form on the, not directrix, it is generatrix, which will form on the workpiece surface. There are two varieties. These are the two varieties which are there in the super finishing operation. One is a plunge type, another one is a roller type. You will come across that one is a plunge type of super finishing. If you see, this type used to finish irregularly shaped surfaces. That means that if you have any type of irregular surface, you can go for this particular super finishing type. This workpiece is rotated while the abrasive plunges into the desired shape. That means that this is the plunge. You are going to apply the pressure on it and you are going to rotate this particular workpiece. So you will get the finishing operation. So for this purpose, this whatever the stone which is there, this may be flexible, this may be a solid. At the same time, you can also go for liquid abrasives here by putting it and you can rotate it. People use like that also. So you can see some of the advanced varieties of super finishing where they can use the porous stone and they just put the abrasive slurry, then they will rotate the workpiece. Some of the advanced varieties they are doing like this, like they can take the porous plunge and they put the abrasive slurry, then rotate the workpiece. In that circumstances the finishing will be slightly better. So there are lot of parameters that plays the finishing operation performance, like what are the abrasive particle size, carrier medium, abrasive particles concentration, the carrier medium, and all those things will play a major role. The another one is the wheel type or the roller type. So these abrasive cups are the wheels basically are used to super finish flat and spherical surfaces. You can go for the flat surface as well as the spherical surfaces using this wheel type super finishing. The wheel and workpieces are rotated in opposite direction. Basically the wheel and workpiece normally rotated at opposite direction, which creates the cross hatch pattern. In this aspect what will happen, you can go for the cross hatch patterns on the surface, not only the finishing but also you can get some pattern. If the two are parallel, then the results in a flat finish, but if the wheels is tilted slightly, now normally you can get concave or convex depend on how you are going to tilt. This is how the wheel type of super finishing will take place. There are two varieties, one is a plunge type, another one is a wheel type of super finishing, and the plunge type uses for its own applications, roller type also uses for its own applications. If at all I required cross hatch pattern, then I can go for a roller one. If I want the flat, if I want the normal one, then I can go for the plunge one. So before and after, what will happen if I am going to use the super finishing operation? The plunge type, if you take, this will erase all by rotation. What will happen? These are all will go. So these are all will go in, then you will get the final surface finish like after finishing. Okay, you will get the shearing. Normally abrasive process will shear all these peaks on the surface to get the good surface finish. The advantages of the super finishing, it increases the part life, that is the component life, decreases the wear because your surface peaks are very less, so the wear will be very less. Close tolerances, you can achieve very better tolerances as per the requirement of the customer. High load bearing surface, if the surface roughness is too low, what will happen? Number of peaks will be very less, so the load bearing area of that particular surface will be increased. Better sealing capabilities, at the same time you can have the break-in period, so elimination of break-in period. Okay. The disadvantages of this particular process, every process will have the pros and cons. So there are some disadvantages, that is called you need a pre-finishing process or a pre-machined process like a grinding or hard turning process, then only you can use the super finishing operation. The cutting efficiency is lower because the chips are very low. You have seen the grinding operation where the chip size decreases from turning to the milling to the grinding operation. If the chip size decreases, what will happen? The specific cutting energy requirements will goes up. That's why the energy efficiency in this particular process will go down, because the chip size in this particular process is still lower compared to the grinding process. So another disadvantage is the super finishing stones are softer and wears very quickly. These are the three disadvantages of the super finishing process. If you see the applications of the super finishing process, you can see how the super finishing process is taken care by the brush. This is the workpiece which is very shining, and these are the brushes which are there, and these are the multiple brushes are finishing the surface. So you can see how the surface is looking like a mirror surface. You can also go for the irregular shapes. This is the overview. The bottom one is just a overview wherein if you see a particular portion, then you can see here. So this is how the mirror like surface finish you can achieve in the super finishing operation. Coming to the machining fluids or the lubricating fluids or the finishing fluids, you can normally the machining fluids in the super finishing operation, basically it goes by the lubrication, because finishing action takes place by the friction or abrasion action. In that circumstances, the heat generation is much less. For that purpose, obviously the person has to go for lubricating type of cutting fluid rather than cooling type. Okay, so mineral oil thing you can go, and even people can go for MQL also. You can see the MQL also people are using, but only thing is that I strongly suggest, with my small knowledge, is that you can go for the pure lubricants, even if you are going for the minimum quantity lubrication application also. So this may increase or enhance the process efficiency. So those people who are interested to take the research in the super finishing is a good area. You can try with the MQL as your one of the thing, like sustainable super finishing operation. So take the plunge type or roller type, whatever is suitable to your nozzle application, where you can put your nozzle and all those things. Plunge type slightly may be difficult, so you can go for the roller type, and you can take up how the performance of the super finishing process from the point of the surface roughness achieved. You can talk, you can go for variation of the air pressure or the concentration of your cutting fluid, or different types of lubricants you can use, and many things you can play. This is about the super finishing process. Now we move on to sandblasting. The sandblasting is one of the mass production process. Okay, so if you see sandblasting, normally it uses the sand particles which are seen here. Sandblasting is one of the most effective way to shape or strip the smooth surface by any foreign material. Normally this process you can give the some shaping, or normally if there is a big casted product is there, if I want to remove some casting layer, the surface of that cast product, you can use this sandblasting. This process can be used to finish the nooks and corners, and you can also generate virgin like of surface, not the virgin surface. So you can use the compressed air to blast the fine sand or other abrasive particles. What I mean to say is that there will be a compressed air, there will be a sand, you just mix internally and send to the component to be finished at with very high pressure, so that the finishing will takes place on that particular object or product. Materials other than the sand can be like a steel grids, steel shots or glass beads, the groundnut shells. Many things you can use. Aluminium oxide, that means that Al2O3 also you can use, but depend on your requirement of your particular application. So the particles you can use variety of particles here. You can see the sand particles, different type of abrasive particles like Al2O3, coal slag, brown aluminium oxide. This is the black aluminium oxide. This A will be black aluminium oxide and C will be brown aluminium oxide. You can also go for beads like of thing. So you can see these are the spherical balls where you can do the burnishing operation. See, sandblasting you can do by, it is one type of burnishing operation. Whenever you just impinge these particles with high pressure on the workpiece, what will happen? This will go and deform the surface roughness peaks which are formed during the previous process. This is how the sandblasting works. The main purpose of the sandblasting is it is used to clean the workpieces and also used for removing the impurities and suspended particles. So you can see here, these are the rims of the vehicles before and after. So how it is cleaned perfectly, so that you can reuse this one by painting it again and again. Clearly you can see here the difference between before and after. This is before, this is after. So how beautifully the sandblasting worked here, before and after. So it can remove the rusted, that is oxide layer clearly, and gives like a virgin surface. It is may not be a virgin surface, it looks like a virgin surface. Sandblasting, it uses the compressed air, at the same time it is you take the abrasive particles, you sieve it as per your requirement, what is the size that you want and all those things, then you can go for the using in the sandblasting. Basically sand is a silica, so or the silica dust. The basic problem with this one is silicosis problem. So this is a chronic lung disease due to the continuous inhalation of silica dust particles, because you are sending with high pressure gas along with the silica dust, that is a sand. What is the problem? People, if they are not going to use proper precautionary things like mask, apron and all those things, what will happen? The silica particles, the dust will go into the lungs of the person. However, this may be prevented by using a protective clothing and breathing supply. So if at all the people take care, or the operator take care about its apron, mask and all those things, you can prevent it. Alternative to sand are glass beads, metal pellets, dry ice, many things also can be used, like these are the particles that you use. If you see the lungs, this is the x-ray of a patient with lung silicosis as the result of the sandblasting. Basically this is the normal one and it is silicosis affected one. You can see people who are watching or listening to the codes, you should careful about the operator. If you tomorrow you may become engineers, so you should provide the operators with proper attire, proper mask, proper dress and all those things, so that the operator will be safe and operator's family will be safe. It is not the operator's health or something, it is the family. Please consider this as a humanitarian grounds, and you can tell the operators that this is what the difference if you wear, if you don't wear and all those things, because sustainability or the sustainable manufacturing is what all people want. The safety precautions, what you can suggest to the operators is, this is how one should not use, this is the wrong way. I mean to say the application I am not saying, this is how the wearing and all those things is not the right way. This is how you can use the apron. So if you can properly wear and all those things, the attire, mask and everything, this is the good way. Okay. So suggest the people that this is what, if at all you are going to work in the sandblasting area. So other things are, there is no involvement of the operator. You can do directly, automatic sandblastings are there. So these machines are available. You can, the company can purchase. At the same time, the people, if at all the component has to be handled, there will be a glove box based cabinets are there. Like if you see in clean rooms, you will have a glove boxes and all those things. Similarly, sandblasting you can do inside the glove box or the cabinet, so that there won't be much problem, and you can even the operator can see from the screen. So these are the some of the advancements in the sandblasting. So there is another one concept called microblasting, or the here also one people can go for the sandblasting and other things. So powder comprised of spherical micro-sized glass beads like silicon carbide, Al2O3 and all those things. Normally these micro sandblastings are used for mostly for biomedical applications like stunts and all those things. Okay. Used for finishing applications like nano finishing. These cannot achieve the nano finishing, but these are all mostly used for the deburring operation. Okay. This is a particular component where I want to do the deburring operation, because there is a pattern generated. Whenever the pattern generated, there is a chance of burst generation on the surface. People who may not know, if this is the surface, if what I am doing, there will be bursts. That means that unremoved metals or smeared metals, I cannot say smeared. So some of the lump of the chip which is adhered to the side edge is nothing but the burr. Okay. These burrs are removed, because whenever, assume that this particular is a endoscope or a chronoscope, what will happen if there is a burr, What will happen if you endoscope or chronoscope, if the endoscope goes into the throat, what will happen? This particular burr will cut away the soft tissues of the human being. For that purpose, you need to do the deburring operation. One of the process that you can do the deburring operation is microblasting. This is about the sandblasting, and one of the advancements is micro sandblasting or the microabrasive blasting. In the microabrasive blasting, you don't use the sand, you can use a sophisticated one like silicon carbide, alumina and all those things. Next one, we are going to the vibratory finishing and tumbling process. So, vibratory ball finishing, the finished products in bulk basically in a container, usually in the presence of abrasive media. You just put abrasive media, you put a components, then you apply the vibrations or the oscillatory motion to the bowls. Mixing causes parts to rub against the media. That means that abrasive particles are there. These will rub against the components and do the finishing operation. Parts are usually very small, therefore uneconomical to finish individually. Basically, if the components are very small, if what all I want to finish individually, that is not economic. The cost of the production cost of the component goes very high. So, for that circumstances, you can go for vibratory ball feeding. Another one is tumbling process. It is normally in a horizontally oriented barrel basically, and the mechanism will be used like a landsliding. So, whenever you have a abrasive particles as well as the components, you just rotate it, what will happen, landsliding type of material removal reaction will takes place. The basic drawback of this process is this is a slow process, at the same time noisy. If at all the tumbling or the vibratory ball finishing is going on, this interaction of abrasive particles with the components, at the same time rotation of the bowls will give large noises, and it occupies large floor area also. This is the tumbling, you can see here. This is the process for the mass finishing and good shaping process, but not the finishing process. I have assume that I have a components with casted components. I want to remove a layer on top, so you can go for this. You can get the shape, but not the final finish. Assume that if I want the nano finish, you may not achieve, but you can get the similar shape. So, non-uniform finishing due to random contacts. So, abrasives are loosely bonded, that means that these are individual, and you are rotating it. What will happen? The contact will be random. So, the surface finish that you are going to get on the component will be random. Okay. So, this is the one variety that is called centrifugal disc tumbling, another one is centrifugal barrel tumbling. These are the two varieties. One goes vertical, another, this is about this axis, another one will go for horizontal axis, like this is the one axis, this will go like horizontal axis. Okay. So, this is about the tumbling again. If you see the diagram of the tumbling, it is nothing but the barrel finishing operation showing the landslide action. This is how the sliding will takes place. That means that medium, what is the abrasive medium will takes place like a landslide like this, and the finishing will takes place. In a vibratory finishing process, what will happen? Alternative to the tumbling, this is one of the alternative you can go for. And vibratory vessel subjected to all parts agitation with the abrasive medium opposed only the top layer in the barrel finishing. What will happen? You just put it here and you just rotate it, and you will get the finishing process. Vibratory finishing, the process times for vibratory finishing are significantly reduced. That means that the products are finished in a mass production. So, the time will be very less. At the same time, open tub permits the inspection of the parts during the processing, and the noise is reduced. So, open tub permits the inspection. There are open tub and closed tubs are there. So, you can go for any type of thing. Media shapes in the vibrating finishing are like abrasive medium for finishing, steel medium for burnishing. That means you can go for two varieties. If at all my requirement is a finishing process, then I can go for abrasive particles. If at all my finishing is by burnishing, normally I can go for a steel media, that is steel spherical balls or any particular shapes that you can generate and use. These are the some of the shapes that are used, like a spear, star, arrow, cone, pyramid, to the pins. Okay, depend on your requirement, you can go for this type of shapes. In the, you just put any one type of shape in the vibratory bowl finishing process and you put the component, then you rotate it, and this will help. So how it will help? If at all I want to shear it, I have to use abrasive particle. If I want to burnish it, I have to use the steel type of particles like this. So now we move on to the drag finishing process. In the drag finishing process, you can see this is also one type of vibratory finishing process, but here the workpieces are held and the abrasive particles are at the bottom. This is also a mass finishing operation. At the same time, large parts are clamped in specially designed holders and then dragged with the rotary motion through the finishing or the polishing media. These are the knee implants. Whatever you are seeing is a knee implant basically, and you put it and you rotate with the abrasive particles, so are the dragged across. That means that your abrasive particles will be also stationary. Now your abrasive particles are there in the bowl, you put the your implants or you hold your components, then you give certain motion to the whatever the moving object is there. Assume that this one is the moving one, you just give the motion to it, so that abrasive particles will interact with the components. Like in this case it is a knee implant, and you can do the finishing operation. Avoid some dents or scratches from the part to part. The beauty about this particular process compared to the previous process is, in the previous process you are just putting all, assume that I am putting a knee implants in it, then I am rotating with respect to certain speed. What will happen? There is a chance knee implant to knee implant contact also, but this will be not there in that particular operation, because these are fixed to certain particular portion of this rotating part, and abrasive particles will have their own finishing action. So applications, normally medical implants you can do, then aerospace you can do, turbine blades, gear components, drill bits, many things you can go for this particular operation. This is a mass finishing operation without touching each other. That is good. That is what we have seen in the previous slide also. Random nature of finishing is taking place, because this is abrasive particles are randomly oriented. As you can see here in the previous slide, the knee implants are on top side, here the components are held inside, and now you rotate it. There are separate motors for each motor is connected here. Assume that this motor is connected to this one, and you can also see here the video. You might have seen the video how it is rotated and all those things. This process normally uses for the edge rounding, like achieving the following, like removes the grinding burrs, stabilizes the cutting edges and extends the tool life. So on, many applications you can use for this one. Normally deburring operation is also then. If you can see here, before processing and after grinding operation and after the polishing operation, how you can change from this to this and this to this, you can see here. At the same time, tool holder, you can see before and after, and the thread cutting tips also. Okay, these are all applications of this particular process. This process can improve the surface quality, reduces the roughness. This is the most important, because as a finishing process the roughness has to go down, and improves the chip flow also. So the drag finishing process, key finishing things is machining parameters like speed, processing time, direction. These are the things. At the same time, in the workpiece also, if you see the workpiece size, workpiece geometry, workpiece material, whether it is a ductile material or whether it is a brittle material, and all those things you can say. And in the machining parameters, you have the immersion depth, how much you are going to immerse, whether you are going to immerse partially or fully, that's all dependent. If you take from the point of drill bits and all those things to be done. In that circumstance, I don't want to finish the shank. There I can go for partial immersing. Then the angle of the holder, at which angle, whether you want to hold like this or whether you want to hold like this, that all you can play. The another key factor is one abrasive medium, okay, where you can use H granules or HSC granules or K granules, 6 granules or QZ granules. These are the varieties of granules are there. These are all you can use as your abrasive particles in the drag finishing process. So drag finishing process also have some product development type of thing, that is you can develop this type of abrasive particles and you can open your own company for this one. This is not a very big task to develop this type of abrasive particles. You can develop and you can sell to the companies who are going to do the finishing application. Summary goes like this. We have seen the lapping process, we have seen the super finishing process, we have seen the sandblasting process, vibratory bowl finishing process and the drag finishing process. These are the finishing processes which are unbonded abrasive processes which we have seen in this unbonded finishing process, and I am thankful for your kind attention for this particular class. Okay, we will see I will see you in the next class. Thank you.